Alright guys, today we're going to be talking about how do I simplify square roots. In Chapter 7, in our next couple lessons, we are going to deal with some square roots, and instead of turning them into decimals, we want to try to rewrite them as whole numbers, even if they don't simplify perfectly. So today we're going to talk about how to do that. Now at any point during this lesson, if you need to pause to write down vocab or rewind to rehear a main concept, please do that. We're going to start off with our vocab words. So first we have a factor. You're going to hear me use the word factor a lot in this lesson. A factor is a whole number which gives us the values that we multiply to get a certain number or product. So for example, the factors of 30 are any two numbers that multiply to 30, such as 15 and 2, 10 and 3, 30 and 1. Okay, the one I don't have written down here is 5 and 6. Those are also factors. So when we think about what are the factors of this number, we're just asking ourselves what whole numbers multiply to get this. Decimals do not count. Now what happens if you're trying to figure out the numbers that multiply and you're coming up stuck? There's not any numbers you can think of. You might have a prime number. A prime number is numbers whose only factors are 1 and itself. Numbers like 13. 13 is only divisible by 1 and 13. If I divide by any other number, I get a decimal. So its only factors are 1 in itself. Actually, this is an entire list of all the prime numbers up to 100. There are prime numbers after 100, okay, but you shouldn't need those. And then lastly, we have a perfect square. Now, a perfect square is a number whose square root is a whole number, or a number whose factors repeat, such as 36 has factors 6 and 6. Okay, the square root of 36 is a whole number. Here are some examples of some perfect squares, going all the way from 1 to 100. Now, there are no missing perfect squares here, so if you're looking for a perfect square and it's not on this list, okay, then that means it may not be a perfect square. There are perfect squares after 100. You just got to think about what is the square root of this number. Is it a whole number or is it a decimal? If the square root is a decimal, then it's not a perfect square. Now we're going to take a look at these ideas and we're going to talk about how do I find the square root of something that is not a perfect square? How can I use factors and perfect squares to do that? So we're going to look at two different methods. The first method is called factor tree or prime factoring. The second method is perfect squares. We're going to take a look at the square root of 60 on both examples. Now if you try to do the square root of 60 on a calculator, you're going to get this decimal. Okay, this decimal actually goes on forever. It just stops here at the 6. We have in the past been taking this and rounding it to 7.7 or 7.75. We're going to learn about how can I rewrite the square root of 60 as a number that has no decimals, but more simplified. First method we're going to talk about is something called a factor tree. Now a factor tree is when we take a number and break it down into its smaller factors. So let's take a look at 60. If I break this down, what are two numbers that multiply to 60? You might be thinking of maybe 3 and 20. You might have thought of 6 and 10. You may have thought of 2 and 30. There's lots of different factors here to use. As soon as you break it down, you're only going to stop once you get to a prime. You're going to break this down over and over again. So 3 is prime. Okay, so that 3 is done. But 20 can go further. 2 times 10. Well, 2 is prime, so I'm done there. But 10 can go further. 2 times 5. And those are both prime. So I've gone this all the way down until I only have primes left over. So now the square root of 60 is turned into 3, 2, 2, and 5, all multiplied together. And if you check this, 3 times 2 times 2 times 5 is 60. You should get that number back. Now what does square root do here? Square root takes perfect squares, or numbers multiplied by themselves, and turns it into one number. So if you look, I have two 2's here. The square root will cancel that out and turn it into a solid 2, because the square root of 4 is 2. Now what happens to the 3 and the 5? They're left over. They don't pair up with anything, nothing happens. Well, we're just going to multiply them back together and leave them underneath the square root. My answer is 2 root 15. I can do this with any number, as long as it's not prime. Now let's talk about perfect squares. Perfect squares means that I'm going to look for a factor of this that is perfect, divide it out, and then give me my remainder. So you want to look at what are two numbers that multiply to 60 where one of those factors is perfect. Okay, you're going to have to do some guess and check here and kind of go through your knowledge. Now if it helps, you have that list of perfect squares on your notes. So you can go through this. Is 60 divisible by 4? Is 60 divisible by 9? And go on and on until you find your perfect square. 60 is divisible by 4. 4 times 15. This gives me two separate square roots to look at. Square root of 4 times the square root of 15. Square root of 4 is easy, 2. Square root of 15 can't go any further. So it gets left as it is. Same answer, two different methods. Okay, this one will take you a little bit longer because you're breaking it down into small pieces. Okay, but it's easy to look at those pairs and know what they're going to turn into. Here, it's going to be less work because you're figuring out what my perfect squares already are, but it's going to take you some guess and check work on some of those problems. Now we have 6 problems to talk about. Let's talk about them really quickly, and then I'll give you guys some time to work on it on your own. So square root of 64, you got to think about, okay, what does this give me? Now a good trick right away would be to think about, is this a perfect square? Because that's going to simplify it a whole lot. So try to think about the square root of 64. Does that simplify nicely? Yes, it does. 64 is 8 times 8. So this one's easy. It's 8. Okay? You are going to have perfect squares exist. But then take a look at the square root of 50. Square root of 50, if I use my calculator, is about 7.07. That's not perfect, so let's break it down. Again, you can use a factor tree, such as 5 times 10, 2 times 5, where you have 2, 5, 5, and take out your pair, 5 square root of 2. Or you could think about, what perfect square can I divide 50 by? You might get 25 and 2, where the square root of 25 is 5, leaving a 2 behind. Let's do one more example together, 72. If you think about your factor tree, you're going to break this down. I might do 2 and 36, 2 and 18, 2 and 9, 3 and 3, where all of these are prime. If I rewrite it, 2, 2, 2, 3, 3. I got a pair of 2's that will cancel, and I got a pair of 3's that will cancel. So that 2 and 3 are going to come out of the square root, and there's a 2 left behind underneath. 2 times 3 is 6, so my answer is 6 root 2. Okay, now again, you can use perfect squares by thinking about what perfect square can I divide 72 by? You got 36. Okay, the first two numbers I came up with. Square root of 36 is 6, leaving a 2 behind. All right, now pause the video, and I want you to try these questions and pause the video, and then after you're done trying these questions, go ahead and replay the video to see if you got them right. Pause now. Okay, let's go over the answers. Square root of 10, you should have saw that there was no pairs that happened here, leaving my answer as just the square root of 10. Sometimes there is no simplifying of an answer, and that's fine. Square root of 150, you should have gotten 5 root 6. And then lastly, and this one was a more complicated one, you already had a 2 outside. All that means is that 2 was already removed, and I would multiply it like we did in the third question. You should get 4 root 6, because 24 simplifies into 2 root 6. So you would just multiply the number that was already there. Okay, now that we're done with this, you're going to go ahead and move to your worksheet. Okay, this worksheet has 20 questions. Some of them are going to be perfect, some of them are not going to be perfect. I expect all work to be shown, and then there's a puzzle down here at the bottom that can help you with finding your answer. The question is, how do you make straight A's? It is a riddle. The answer will show up down here. Although what I'm more concerned about is, can you do the questions in these boxes? All right, guys, good luck.